Here's an Ampeg VT40, made between 1976 and 1979. I used to own this amp in the early to mid 80s, and then I traded it to a friend for this bassman because he needed a guitar amp. And then eventually it got set in a building, unheated, and you can see it's really gotten dirty, and also kind of, I don't know if this is showing up. Here we go. Kind of mildewy. Yeah, it stinks. So, alright, battery ran down. Okay, yeah, taking a quick look at the panel here. 2 channels. It's got the distortion control that no one likes. Maybe somebody does. And then the key to it are these 2 rocker switches, which select frequency bands and then the mid-range. The reverb on these amps is more of like an, it's a spring reverb, but it's more of like a hall effect. It's really big and different from the Fenders. Not that Fender isn't cool. So, and this thing's really dirty. This thing met the fate that a lot of these Ampegs did back then. The 10-inch speakers would blow out, and since it was cheaper just to buy one speaker, or maybe you have one, people would make these homemade baffle boards, stick it in there, and get it back running again. Look at the back of it once. Yeah, you can see Radio Shack speaker. Yeah, even the cord is, it's just covered with mildew and stuff. Normally I just kind of wipe down a cabinet, but this thing's going to have to be taken out and really scrubbed down. Anyway, look, yeah, it's a Radio Shack speaker, and for some reason, maybe it's loose or something. There's a effective, but maybe not OSHA approved. It's also bending the back of it. Let's see if it's going to fall out. No, it's in there sturdy. Maybe it was vibrating or something. So anyway, yeah, look, here's the 7027As. I looked at them, they both are that number, but look, they're different physical sizes, made by different manufacturers. Yeah, original caps are still in there. I plugged this in and tried it for a little while, and the rocker switches are very dirty, so there's a lot of, in and out, intermittent stuff there. Yeah, that might be an issue. Better put a 90 degree on there. So I did plug it into another set of speakers, and man, it got way louder and clearer, so that's going to have to go. We'll have to see what we can do there. It'd be nice to fix up the baffle board and put maybe like 2 10s in there. That's what I played it through, and boy, it sounded pretty good. Yeah, another reason I'd like to do the baffle board different is because since the new baffle board is screwed to the edges of the old one, it pushes out the grill cloth, which, bangs it up for one, and it ruins the look of it too. Should be recessed back in. Let's see if we can do something about that. Hey, no laughing at my gloves. There we go. Alright, that's better. Now the mildew's gone. Still has plenty of the original underlying dirt, but at least you can work on it. Yeah, there's the remnants of probably a spilled beer. But, safe to touch now. Well, I was digging through my stash. I thought I had a couple of these old Ampeg handles. Yeah, it fits right in the old holes. Somebody else must have. There's 4 holes here, and 2 here, 2 there, and 2 here. So somebody must have had something screwed in. But These are the original handle, which, man, it must have been, I guess I was a lot younger then, but hauling this thing around with that one handle. Yeah, there it is. This one's bent. So, yeah, this one's bent a little bit. See, the screw's bent out. I'll have to straighten that out. But, yeah, it will, where is it now? Oh, it's there somewhere. There it is. Yeah, it's there somewhere. Yeah, it's bent out. It won't go in. But anyway, yeah, so that's, now if I can find the middle section, be all set. Alright, so I'm going to turn this thing upside down, because that way I don't have to hold it with one hand and try to unscrew it with the other. It's got two screws on each side that go into this heavy metal mounting plate. Pull you off here. There's the tattered remains of the schematic. It's upside down. Here we go. Whoa. Let's see. Yeah, I mean, I can find it online, but at least most of it's there. All right. Well, let's get her on the bench. Alright, here he is up on the bench. Look at the size of these transformers. Pretty big. I think that's the output transformer, because there's the speaker jack. Here's the 3 cans that we have to replace. And there's multiple capacitors in each can. And here's the power transformer. You can see that the lamination is larger. It's got a larger footprint than that one. Yeah, they use some big transformers in these amps. That's why part of the reason they're so heavy. Let's get these plates off here, and then we can look and see if any of those components are really hot in there. Now, besides, I think there's a couple of capacitors that will need changed, and we'll have to look at those. These 2 wings are screwed to the side of the cabinet, and they've got these little rubber cushions that kind of keeps the whole chassis from vibrating a lot. And with the amount of volume these amps put out, that's not a bad thing. They're kind of floppy, so you can't just turn it upside down and rest them on those when you're working on it. But if you put this part back on, screw it into the sides here, then it should, then we can flip her over and get in the top side. Alright, covers are off. I noticed something right away here. See if I can get in there. This guy right here, this power resistor is he gets warm, and this capacitor, because of that, has gotten quite hot. This wire here is discolored. It's gotten hot too. And check this out. This is look at this capacitor, how cracked it is. It's one of the, you can see that here's one over here, tropical fish capacitor, because they have those colorful stripes. It's kind of hard to see because we're up above it, but then look at this one, all cracked. So those are going to require some attention. Yeah, those resistors they look like they have gotten quite warm. Not sure what's going on there. I'll have to check those out. Well, we'll get in there and investigate. Yeah, here's yet another cooked resistor. Right here. Yeah, these guys, yeah, they've definitely gotten warm. And this, I don't know if we can see it, but these two electrolytics here. This guy's bulging and it looks like it's leaking, and this guy's leaking something here too, so they're all going to have to go. Well, I've never seen an amp that had so many cracked resistors. You can see all three of these, maybe you can see that, all three of them have small cracks in them. Look at these guys here. Basically falling apart. This fella here has no skin at all left on him almost. These three guys are getting replaced too. That look like they've got extremely hot. Let's see. Yeah, there's a guy back in there. Another one. And a lot of them that aren't really, there's cracks in them that aren't showing up with this camera. But they are there. But these capacitors, man, they are really, this guy here takes the cake here. Oops, sorry about that, sir. Wow. Yeah. Yeah, it's a good example of why manufacturers should not put the tube sockets on the circuit board. Because this is hanging upside down, and all that heat just goes on the board and really messes stuff up. But you know, they do it because it's cheaper to do it that way. You don't have to drill a hole in a chassis and screw a socket into the chassis and wire it up. You just put it on there and solder it in. But yeah, well, at any rate, we'll get her fixed up and she'll be good for another 50 years. One cool thing that Ampeg did is each component has a number. You know, like diode 205 or resistor 221. And those same numbers are on the schematic. And they're also in the back of these printed circuit boards too. So it really makes it easy to find stuff. Less tracing. It's kind of cool. I don't know if, yeah, I guess people still do it. Now there's the schematic. A little tattered, but still working. You gotta give a hand at Ampeg. They're the only manufacturer that I know of that can put the reverb tank, spring tank, right in close to the circuitry of the amp. The Fenders always put it down in the bottom of the speaker cabinet, because if you get it any closer, it hums like crazy. But these guys have figured out a way to do it. These will have to be replaced. I'm going to have to drain those caps off too, because they could have 500 volts on them. Now, getting ready to change the filter capacitors. I'm going to do one at a time. And I did make a little drawing here so I don't, you know, get lost. One unusual thing about the Ampegs is on a Fender amp, these are the grounding pegs. They're you can see here's the grounding pegs. They're directly connected, and they're actually part of the outside case. And on a Fender amp, that goes right into, those tabs go right into the chassis, so that the amp can is grounded, the outside of it. But Ampeg doesn't do that, at least on these models. As some other YouTubers have pointed out, there's also a voltage potential between these cans. And that's why they have those cardboard sleeves on them, which I will be taking off and, you know, putting on the new cans so no one gets shocked. But yeah, you can see these insulative like wafers. It's like circuit board material. So the ground lugs are going into that and not into the chassis. Yeah, one of the many unusual things about the Ampeg amp. Well, I wanted to reuse the cover, and I guess I'll be able to do that. I had to cut a slice in it to get it off, because look at the amount of gunk they put in there to keep it on. Yeah. Sometimes you'll see where they just put a little tiny bit and you can slide it off, but that was not the case on this one. Okay, I got the cardboard covers off all 3 cans, and you can see they really gooped them up. Yeah, so there's still some in here too, but I don't know. We'll see. If not, I'll have to make something. All the filter caps are now in, and it's time to get to work on the burnt resistors that are located on the other side of these circuit boards. Yeah, here's one of the 100K resistors. It's drifted up to 171K. Look at this crispy fellow. He's actually still working, although it's supposed to be 180 and it's 252. Still hanging in there though. And there's a lot of old flux built up between these pins, so I'm cleaning that out. I mean, it was really thick. I don't know if it was there initially, or it just kind of came out over the years of extreme heat. But man, so I thought I'd clean it up a little bit. There's all the parts I replaced. Most of them have drifted quite a bit. Some of them were surprisingly close. Like, for instance, this guy wasn't really too far off. So it's kind of like a ceramic capacitor, but the color code skin burnt right off of it. Yeah, I was surprised with that one. Okay, got the cardboard back on the cap cans. It's they're glued on, and I have some rubber bands around holding them until the glue dries. And I got a sticker to let the next person know when they were changed. Got the new resistors in here, new capacitors. So we're just about ready to check the bias. Alright, getting ready to set the bias, and see, the bias circuit is here. Comes off the transformer through this fuse, and we're looking for about minus 28.5, 30, whatever, about there. If you look, that's F. So if you look up here, there's F, and it comes in right between these 100K resistors, 211 and 212. And that is these guys. Oh, where are they? Right here. Where's my pointer? Where did it go? Okay, there it is. Yeah, these guys right here. If I could get them in focus. It wants to focus on the wire, but anyway, yeah. 211 and 212. Okay, so here's the meters. We're gonna bring the variac up slowly because of the new caps. A little bit more info about this amp. Yeah, I used to own it back in the early 80s, and then traded it to a friend because he needed a guitar amp, and he used it for a while, and then he just didn't use it anymore, so it ended up in a storage building. And after a while, I think there was some water damage, in the building. Anyway, what happened is then a mutual friend of both of ours bought it, and so I'm bringing it back up to snuff for him. It's never had any filter caps or anything, so replacing all those and a lot of burnt resistors, and going to check the bias. And also on note number, let's see, what note is there, what number? It's number 6 on the schematic, note number 6. The two 7027 output tubes may be replaced with 6550 tubes at the customer's discretion for improved performance. So that's what I'm going to do. I don't have the tubes in it right now. I just want to get an idea if we've got bias voltage. It looks like it's going to be okay. We're up to 84 volts. This is the input voltage, and this is the DC bias voltage. And it looks like it's going to be in the ballpark. Yeah, I can't get up past 117 today. I might have to put a booster transformer on the Variac. But anyway, it looks like yeah, the tubes are lighting up. We got 31. That's enough. That's in the ballpark. Tubes are lighting up. We'll see. These are pretty nice for working on, really. You can get in this side, and you come around here, and there's the other end of the side of the board. And notice this board has the component numbers written on both sides of it, which is really handy, but when you get down here, it's like, oh, they must have quit doing that. Yeah, so anyway, so I think I'm gonna I guess the next step is to stick the tubes in, bring it up, and watch the plate, or the stick the tubes in, bring it up, watch the current through the tubes and the plate voltage, and we'll see what that is. Alright, I just want to get an idea of what this plate voltage is going to be. Again, this is still the bias voltage, and this was the plate voltage on one tube, so let's crank it up and see what we get here. These things are, I remember these things are known for like putting out a lot of volts. Let's see. Alright, we're up all the way. Yeah, look at that. 594 volts. Well, that's good. The tube manual says 600 volts maximum. So I guess we're making it. Alright. Alright. I'm going to try some tubes in it now. When I went to put the 6550s in, I had to remove the tube retainer rings because the diameter of them was not big enough to go out around the base of the 6550s. So I took them off, and if it becomes an issue, I will have some, I've got some Marshall style ones that I can put in there. I got a homemade bias probe here. I just took a tube socket and soldered it onto the male part of another old broken socket, and I've got the cathode to ground interrupted here, and this wire goes to the meter right here, and that's how we're going to read the current through the tube. We've got 549 volts times 72 milliamps, and that equals 39.5 watts. Okay, so I'm going to shut that down. This is a 35 watt tube, and normally you would run the tube about 70% of its maximum capabilities. So, or that would be about 25 watts. So that's what we're going to do. Okay, to get the bias where we want, I believe this resistor right here, R215 22K, should be increased to make the voltage more negative. So what I've done is I've pulled off one leg of the 22K right here, left the other one in there, pulled this one off, and hooked up just a 100K potentiometer. It's set at 0 now, and it's just temporarily clamped on there. So I can bring this up, hopefully, and achieve what I want, and then shut her down, measure the pot, and then I'll know, add that to the resistor that's there, and I'll know what I need. And we'll see if that works. Alright, we've got 560, now let's try that again. We've got 570 times 45 milliamps, and that's 25.5 watts. What if we take it down just a tiny bit? This pot's touchy. I should probably have something that's a little less. Let's see here. 0.0444 times 566, 25.1 watts. Okay, 564 volts, 44 milliamps, about 25 watts. So we will, now what we'll do is measure this, the potentiometer, see what its resistance is, add that to the 22K, and that will be the resistance needed to bias the amp correctly. Alright, let's see what our resistance reading is. We'll connect, you can see that, connect on this lead of the capacitor, or the capacitor, yeah, the potentiometer, and on the other side of the resistor, I'd say 30K would probably do it. Okay. Okay, so we got two resistors joined in series. Let's see what we got here. We got 43 milliamps times, let's say 569, about 24.5 watts. So let's call it even there and see how that works out. Well, the bias seems to be creeping upward. We're up to 50 milliamps now, and at 560 volts, that's like 28 watts. So I'm going to keep an eye on this and see if it, hopefully it will level out, and then I will just put a higher resistor in to take care of it, but keep an eye on it and see what happens. It's been holding at 43 milliamps for a while now, so I think that's okay. Let's see, we've got 560 times 0.0433 equals 24.2 watts. So I think we're just going to stick with that. The bias is all set. The jacks are all clean. I cleaned the pots, which is not easy to do on an Ampeg. And so I guess we're ready to put her back in the cabinet and give her a try. Quit it. She's all back together again. Check this out. Got this straightened out. No more grill claw sticking out. You got the nice edge here, which is the way it should be, recessed a little bit. Really cool. Good handle back on there again. Yeah, I'm going to leave the side handles because they're easier. I may have put them on sometime in the distant past. I just can't remember. Hey, Mr. Ampeg, how's it going? Well, I feel a lot better since I got those new capacitors. Thank you. Hey, no problem. Let's jam.